let's look at some trigonometric functions and their limits. One famous function is sin x over x, and I'm trying to take the limit as x goes to 0. So, as you see in this table, it's going to approach 1. So the limit is going to be 1. So let's see if we can enter that. So I put these values in the table. So to get to table, stat edit. And I entered 0.1, down, 0.01, down, 0.001, down, and so forth. And then some negative values, negative 0.01, negative 0.001, negative 0.0001. All right, so to just duplicate that table. Now I'm going to go to L2, push enter. I will enter sin x over x, just like I did before. Sine of, instead of x, I have L1, which is second one, divided by x, which is L1 again. When I push enter, you're going to see it starts 0.9999. It approaches 1, and you can clearly see that. So we can say, okay, the limit as x goes to 0 of sin x over x is 1. Now that we are done with this example, let's go to the next one. How about limit as x goes to 0 of sine of pi over x? All right, I'll do the same kind of thing. So I'm going to put, things like, 1, and then I will get 0.5 and 0.25 and those kind of things. I'm going to enter these values. F of 1, f of 1/2, f of 1/3, f of 1/4, f of 1/10, f of 100th, and so forth. So, and I'm approaching 0. All right, so I pre-entered those. So I'm putting everything in L3. I start with 1, and then 0.5, which is 1/2, 0.33, which is 1/3, and so forth. So I entered these values in there. And when I did it by hand, I got 0. So I go, okay, well, is the limit 0? So let's double check that I did those by hand right. Hit enter. Now I'm going to enter sine of pi, and pi is going to come from here. Let's try it one more time. Oops. All right, pi over x. In this case, it's going to be L3. So I have to go get L3. And let's push enter. Let's see what happened in there. Oh. Let's go in here because this is just, I will delete that one. 0.1, 0.001, that's what I meant. 0.01. Here we go. I entered that one wrong. And then 0.001 and so forth. Okay. Because it says here divided by 0. What are you doing? All right. So let's put enter. So I'm going to enter sine of pi, second pi, divided by L3, which is second 3. Push enter. Guess what? It is correct. So I calculate those right. I get zeros. All right. Well, is the limit 0? Yeah. No, it isn't. Let's look at it. This guess of 0 is not right. Let's look at the graph. You need to look at the graph in this particular case. All right. So let me get that out of the way so that we don't get confused. I have sine of pi over x, and I will just zoom stack that one. Go to zoom, And let's get a zoom standard. What does it look like around 0? It looks like it's going down and then doing something fishy. So let me kind of change my Y. So to do that, let me show you the zoom box feature as well. Here is zoom box. You can go around wherever you want to zoom in, and then push enter and put a box around it. Go down and then go to the right. See, I put a little box in there. And let's look at that. Enter. You see it? That's kind of interesting. Let's go zoom in a little more. I will go zoom in. You can either change the window with the window, or you can zoom in or zoom box in. Which one do we want to do right now? I will do zoom box right around here. Zoom box, and I will go right around there and put a little box around there because I am not sure what's going on. Okay, enter, down, to the right. But it really get close. That looks like close enough. I don't know if it is having a hole or whatever, and then let's push enter. Watch. Alright, what I see in here is correct. It is oscillating infinitely many times around 0. What does that mean? When I approach from the right and from the left, I cannot really nail one value. It is oscillating at 0. That means the limit does not exist. So my first guess was not right. So please be careful when you do limits with your graphic calculator so that you don't get in trouble. Now let's look at some examples of infinite limits. This particular example is 1 over x squared, and I want to look at the behavior of that around 0. If I want to graph that, I go and enter 1 over x squared using x with this button. And if you have anything else in there, make it inactive by going to equal sign and enter so that it doesn't plot. And then I will just do a zoom stat and let's see what it looks like. It looks like there is a vertical asymptote there. But what is the limit? Is it going and actually hitting a number over there? I am not sure. So, well, you can actually guess, but let's assume we don't know. Alright, so let's go and use the stat edit feature. And I went ahead and entered 0.1, 0.05. So I'm getting close to 0 from the right. I will do getting close to 0 from the left. And so I entered those values in here. Now I want to enter the 1 over x squared in L2, so push enter. 1 over L1 squared, here we go. And you square it. And let's push enter. Look what happens. It actually gives me a bunch of numbers, 100, 400, 40,000, and those kind of things. And how do you interpret that? This is a very big number, and I can actually see it. When this number gets very, very small, this number gets very, very large. But your calculator is not saying it's infinity. It's just telling you it's a very big number. All right, so in fact, it appears that from, we are going to see from the graph, and I will focus in a little bit, that the values of f of x can be made arbitrarily large by taking x close enough to 0. So they get very, very large in here. Therefore, the limit as x goes to 0 of 1 over x squared does not exist. All right? So remember how the graph was. It does not exist. It gets very, very large around there, but it doesn't exist. It keeps on going up. Now, how do I write that in calculus? I write limit as x goes to 0 of 1 over x squared equals infinity. But that doesn't mean that we are regarding infinity as a number. But it doesn't also mean that the limit exists. It means that in this particular way, the limit does not exist. And it's just this way of saying it. 1 over x squared can be made as large as we like by taking x close enough to 0. All right? So, those are called infinite limits, and we write it like that. If you're approaching a number of limit of f of x equals infinity, so that means the values of f of x become larger and larger or increase without bound as x becomes closer and closer to a. In this case, a is 0. All right? Now let's look at another example. 2x over x minus 3. What does that graph look like? I'm going to make this inactive and this active, and I will just graph it. Look what it looks like. It looks like it's going down this way, going up that way. There is a vertical asymptote in here. All right, so I'm going to do like one-handed limits. Limit from the left, limit from the right. And I know that when I go approach 3 from the left, according to this, you can actually trace that. And look what happens. You see that value? It goes smaller and smaller and smaller. And now you do the same thing on the right. It gets larger and larger and larger. You can say, well, on the right, it's going to be positive infinity. On the left, it's going to be negative infinity. All right? How can I see that with a table? And you can just go close in on it here, but I will also do it with the table. Let's go and start edit. I will enter, here we go, values from the right, 3.1, 3.01, 3.01. So I'm approaching 3 from the right. And I will do the same thing from the left, 2.9, 2.99, 2.999, and so forth. And now I will look at the behavior. The behavior is push enter. You're going to put 2 times x, 2, L4 in this case. L1, where is L4? Right here. Okay, divided by, parentheses, L4. Minus 3. Here we go. And let's push enter. Look at the values, 62, 602, and so forth. It gets very, very large, indicating that it's positive infinity. And here, it's negative, very, very negative, large negative number, negative 6,000 or so, indicating negative infinity. So that's another way of saying the limit doesn't exist. It goes to negative infinity from one side, positive infinity from the other side. The limit does not exist, and actually there is a vertical asymptote at 3. Here's the precise definition of a limit problem. One example. How close should x be to 3 to ensure that y is within 0.1 steps away of 2? Here's my function, y equals square root of 3x minus 5. What does that look like? I will go and put it in. Square root of 3x minus 5. Make sure you put x from this button. And the square root is right here. And when you graph it, it looks like that. So I would like to, where is 3? I will trace it. Okay, I want to go to the right. Here we go. Around 3, do you see it? Around 3, around 3, around there. Okay. So I am in the vicinity of 3 here. How close should x be to 3? How close am I going to get here? so that y is within 0.1 steps of 2. That means it's going to be 0.1 steps up, 0.1 steps down. So I can go and enter y equals 2 minus 0.1 step or 2 plus 0.1 step. All right? Now let's look at it. Here's one, here's the other one. Now what I'm going to do, I'm going to actually go and focus in there. I'm going to do zoom stat, or you can actually go and change the window. I will do the zoom stat in the vicinity around here. So zoom. No, I'll do the zoom box. I'm sorry. So let's go and where is my little pixel? Here it is. Here's my cursor. I'll go up. And I will be here. So let's go enter, pull it down, pull it to the right. Okay, I am about there. Let me go down here so that I can see the X. Enter. Do you see it? Here's one. Here's another one. I'm actually looking for this value and that value. That's going to tell me if I want to stay within this distance here, I need to stay within these two lines. So how am I going to find that? Now, there is a feature called an intersection feature. I will actually go and zoom in a little more with the zoom in feature. Okay, let me go in a little bit so that you can see it. I'm going to go in that vicinity. There we go. Enter. Now it will give me a little bit close up. Oh, I went too far. Okay, let me go back. Zoom in. Let me zoom out so that I can zoom in a little better. I will go to zoom standard first so I can see what's going on there. And I will go and zoom box to this a little bit better feature, or just enter the values. I'll go zoom box. Okay, where am I? Here it is. I can see the cursor a little bit. Up. Up. All right, to the right. I'm going to enter down. To the right. Okay, so enter. Here we go. Now I can see it. Okay, here's one line. Here's another line. Now what I'm going to do, it looks a little different than this one because I have a different window. So I'm going to go to the calculate feature, and it is right here, second calculate. And there is this feature that is very good, intersection. Push enter. Now it will say first curve, which one do you want? So the one that's the curvy one, I'm going to pick that one as my first one. Push enter, and it's going to say, which one do you want as the second one? Okay, let's say I want to find this intersection. This one and that one. So I'm looking for that value. Then you push enter. You have to guess because it's using Newton's method. And bam, it got it. It says X is 2.87. Do you see that? And here it is. You do the same thing with the other one. You have to go in the vicinity of the other one. All right, so let's go second calculate. And I'm looking for the intersection. And intersection of what? The curve with that line. Here's my curve. And with this line, not that one, but this one. This one. Push enter. Yes. There it is, intersection. It went and got it. 2.1. So when my y is within that region, my x is within 2.87 to 3.136666. And actually that's the end of the answer. So you can do that. Usually the calculus questions are going to be, they'll give you the range for y, they'll ask for range for x. So the delta epsilon business. So you actually found it. And this is the end of this problem.